some examples. Let's start with sine of 150. I am going to start this off by graphing, sketching the angle. So I've got 90 degrees, I have 180 degrees, and so 150 is going to be between 90 and 180. I start my initial angle here. 150 is going to be about right there. And so that means that my reference angle starts with my terminal side, and it's going to be right there. So I need to figure out how big this reference angle is. I'm going to do that by taking 180 and subtracting 150, because that was 150 degrees. That leaves me with a 30-degree angle. Alright, if you want to make this into a triangle, just so you can kind of keep it the same as what we did before, I know that this angle right here, where I had that theta, is really 30 degrees. If we go back and think about our 30, 60, 90 triangle, and I know I just went over this, but it's really important that we know how to do this. This hypotenuse, the hypotenuse right here, is always going to be 1. When I don't give you the ordered pair, we're just going to assume that that's 1. It's called the unit circle. We'll work with that later. That's a hypotenuse. HSL says to get to the short leg across from 30, we divide by 2. So that gives me 1/2. Then to get to the long side, we multiply by radical 3. 1/2 times radical 3 is radical 3 over 2. This is all going to help me find my missing, or my ordered pair. Here's where my ordered pair is, right up here, this point. So that ordered pair, let me get rid of some of this other stuff. So think about this. If we're going to start at the origin, we go to the left. We're going back. So we're going to the left, negative radical 3 over 2. And then we're going to go up, so that's positive. That would be positive 1/2. So I'm just matching that ordered pair. I found that ordered pair by using the 30, 60, 90 triangle. Now, what the question was, sine of 150. Remember, sine is equal to the y value. There's the y value. So the sine of 150 is equal to 1/2. Sine 150 degrees is equal to 1/2. Let's try another one. Secant 135. So my first step is to figure out where this is as an ordered pair. So I'm going to make my xy axis here. Let's start over here a little bit. Alright, I've got 90 degrees and 180. So 135 is going to be between 90 and 180. My initial side, 135 is somewhere right there. So this angle is 135 degrees. The reference angle begins with the terminal side, is on the x-axis, and I'm going to go ahead and just make this into a right triangle. The reference angle right there, I'm going to find by taking 180 and subtracting 135 to give me 45 degrees. So my reference angle is 45 degrees. So I'm going to change that and put 45 degrees right there. Now we're looking at a 45, 45, 90 triangle. So I'll draw this down here so I have a little more room to work. Remember, the hypotenuse, the radius is always going to be 1. I know that these two sides are the same. To get from the hypotenuse to either leg, I divide by radical 2. 1 divided by radical 2, can't leave it like that, so multiply top and bottom by radical 2, I get radical 2 over 2. Alright, now I just have to figure out, looking at my ordered pair, I'm going back up to my triangle here. I need to figure out what that ordered pair is. So from the origin, I go to the left. So that makes my x value negative radical 2 over 2. And I go up, my y value is positive radical 2 over 2. It's just an ordered pair. All right, let's go back to the original secant. Secant is just 1 over cosine. So if I know what cosine is, remember cosine is 1 over x, then all I have to do is flip it. So here's my x value. It's negative radical 2 over 2. Let me get rid of this triangle here. All right, so if I know that cosine is equal to negative radical 2 over 2, that would make secant negative 2 over radical 2. Again, I can't leave it like that, so I multiply the top and the bottom by radical 2, and I get negative 2 radical 2 over 2. Lots of 2's. Those simplify, so my final answer, secant of 135, is equal to negative radical 2. Let's try another one. Sine of 240. All right, let's start by graphing the angle. 180 is to the left, 270 is down at the bottom. So I know that 240 is going to be somewhere between 180 and 270. I'll just make my angle there. All right. Reference angle begins with the terminal side. I'm going to come up to the x-axis here and make it into a right triangle. The whole thing, remember the whole thing here was 270. So this time I'm going to have to do 270 minus 180. 270 minus 180 gives me 60 degrees. So my reference angle right there, the angle that I need to refer to do this, is 60 degrees. If we go back and look at the 30, 60, 90 triangle that I drew before, it would be the same idea. Across from the 30 degree is always going to be 1/2. So the 60 degree across from the 60 degree is always radical 3 over 2. So I know that this side is radical 3 over 2 and this side is 1/2. I just need to figure out what my ordered pairs are. So from the origin I go to the left and then I go down. I'm in the third quadrant, so both of my ordered pairs are going to be negative. Now the chart that I was showing you before is just all of these numbers. If you look back up at that, you'll notice the 60 degree, your x value is 1/2, your y value is radical 3 over 2. We're just figuring out if it's positive or negative. So if you'd rather memorize that chart instead of doing 30, 60, 90 triangles, that is definitely an option for you. All right, sine is just the y value. There's my y value. So the sine of 240 is negative radical 3 over 2. Let's try some more. All right, now we're switching to radians instead of degrees. So again, if you just have the chart memorized, or you always remember 30 degrees matches up with pi over 6, 45 always matches up with, or is actually the same as pi over 4, and 60 degrees is the same as pi over 3. That'll help. All right, let's start with D here, cosine of 7 pi over 4. So I've got pi over 2 up on top. That's not going to help. To the left I've got pi. That would be the same as 4 pi over 4. And to the right I've got 2 pi, which would be the same as 8 pi over 4. So I know it's somewhere between those. Let's come down here. This is really 3 pi over 2. I want it to be a denominator of 4, so multiply by 2, and I've got 6 pi over 4. So we can see that 7 pi over 4 is going to be in that fourth quadrant. So I start right here, I come all the way around. There is my 7 pi over 4 angle. My reference angle is right here. I'm going to make it into a right triangle. Now what I need to figure out is what that ordered pair is after I figure out my reference angle. So reference angle is going to be 8 pi over 4 minus 7 pi over 4, and that gives me pi over 4. Remember, we said pi over 4 is the same as 45, so that's really just a 45 degree angle. 45, 45, 90. is always going to be radical 2 over 2, radical 2 over 2. We just have to figure out if they're positive or negative. From the origin, you go to the right, so that's a positive x value. And then the y value, we're going down, so the y value is negative radical 2 over 2. Cosine means the x value. There's my answer. Cosine of 7 pi over 4 is radical 2 over 2. Let's try another one. Negative 3 pi over 4. So negative angles just go in the opposite direction. All right, here's 0. If I go, remember these are going to go backwards. We're going to go in this direction. So I have this, it would be negative pi over 2 or negative 2 pi over 4. So not quite enough, so I'm going to keep going. Negative pi would be negative 4 pi over 4 again. Again, I'm just trying to get common denominators. Negative 3 pi over 4 is going to be somewhere right in between those two. So my angle comes all the way to there. My reference angle makes a right angle with, or makes an acute angle with the x-axis. If I want to figure this out, I'm looking at 4 pi over 4, and this angle was 3 pi over 4. Now I know they're both negative, I'm just trying to find the difference between them. So the difference with 4 pi over 4 and 3 pi over 4 gives me pi over 4. So I've got another 45, 45, 90 triangle, which makes my ordered pair radical 2 over 2 and radical 2 over 2. Since I'm going to the left, my x value is negative, my y value is negative. So, my ordered pair, I'm out of room now, my ordered pair here would be negative radical 2 over 2, negative radical 2 over 2. Tangent means to do sine over cosine, or y over x. If you notice, your x and your y values are the same. If you divide something by itself, it's going to equal 1. So tangent of negative 3 pi over 4 is equal to 1, because we did negative radical 2 over 2 divided by negative radical 2 over 2. Cosecant. Cosecant is 1 over sine. So if I find my y value, I can just flip it. 11 pi over 6 is, let's look at this graph here. Let's look at sixth. This would be 6 pi over 6. And if I went a full circle, 2 pi would be 12 pi over 6. So it's going to be pretty close to that full circle. All right, start right here. I come all the way around. There's 11 pi over 6. Which means my reference angle right here is whatever 12 pi over 6 minus 11 pi over 6 is. That gives us pi over 6. Pi over 6 is the same as 30 degrees. So, the 30-degree angle. Remember what I said? Across from a 30-degree angle, we're always going to have 1/2. So this value is 1/2, which makes the other one radical 3 over 2. Those always are paired up. From the origin, you go to the right, so the x value is positive, and then you go down, the y value is negative. So my ordered pair would look like this. Radical 3 over 2, negative 1/2. Sine, remember, let's find sine first because we can flip it. Sine is the y value. Sine is negative 1/2. If sine is negative 1/2, cosecant would be the reciprocal of that. The reciprocal of negative 1/2 is negative 2. So cosecant of 11 pi over 6 is equal to negative 2. Okay, two more.